Hi everyone, welcome to this new tutorial. Today we will be building a Kirby-like platformer using TypeScript and the Kaboom.js library. So Kaboom.js is a library for making games and it can be used with TypeScript. And here I'm just showcasing the project we're going to build. So here it's a Kirby-like character that can swallow enemies and shoot stars once it is swallowed. And then here you have a beautiful level layout. By the way, I made all the assets myself. And then when you get hit like 3 times, you respawn to the original position. And that's basically it. So let's jump right into making a game like that. What you're going to need for this tutorial is, first of all, I assume a basic understanding of TypeScript. So maybe brush up on TypeScript, just watch a tutorial or something before following this tutorial. And I'm going to also use Node, so you need to be familiar with Node. So here, I'm going to open up a terminal window, and I'm going to set up the project differently than what you're used to if you have watched my previous tutorials, is that usually I would need to use index.html, etc., and then paste the links to the libraries or use JavaScript modules. Here we're going to use a bundler. It's called Vite. So I'm going to do npm run, not npm, npm create at Vite, create Vite at latest. And then dot, so that we specify that we want the project to be scaffolded inside the current folder. So by the way, I'm using VS Code for this tutorial. I recommend that you use it as well. You can install it, etc. Now, if you're familiar with TypeScript, you're probably using VS Code already, so I'm just going to go over. So after having done npm create vite at latest, we're going to select the vanilla template and then the TypeScript template. And then you should have the following files. Now we're going to delete vite.svg. We don't need that. Also, we're going to delete everything that is within the source folder, but we're going to keep the source folder. And then here, I think, here it doesn't matter. Really, you can just leave it as is. It doesn't matter at all. So let's get our assets. So you will find the assets in the description. And yeah, so it's basically just one file. This file contains everything we need. By the way, during the tutorial, we will be drawing our map using an external editor called Tiled. And then we will basically pass this info, this export to our JavaScript to take care of drawing. So I see that the source folder is gone, so I'm gonna have to recreate it. Here we go. So now what I'm gonna do here is I'm gonna create all the files we're gonna need for this project right from the get-go, so that it's gonna be easy to follow. So we're gonna need a constant.ts file. This is for our constant. We're gonna need a entities.ts file. This is going to be the file used to contain the logic for our players, our mobs, enemies, etc. We're gonna also have a Kaboom ctx.ts, which is where we're gonna initialize the Kaboom library and export its context and then use that elsewhere. We're going to also have a main.ts, of course, that's the entry point of our project. We're going to need a state.ts to hold general global state of the game. So this is useful to know when to move on to the next scene, for example. And then finally, we have the utils. Utils is just going to contain one thing, I think, just related to making the map, basically. All right, so let's go to main. And before doing all of that, I forgot, we need to do npm install, which is going to install the dependencies. But we actually, I should have done npm install Kaboom as well. So do this. And this is going to put Kaboom accessible in your project. So once you have this, we can basically, we're going to need the terminal to start a server in a moment. But yeah, that's basically it. Now here, let's import Kaboom from Kaboom. This is how you import Kaboom here. And then, actually, it's not here at all. We're gonna go to the Kaboom context and do this here. So import Kaboom from Kaboom. Once this is done, we're going to go to we're gonna create our context. So basically it's a way to initialize Kaboom. So I'm gonna export K, which is going to be the Kaboom context. We're gonna use this constant everywhere when we need to use Kaboom related functions and functionality. Okay, so to initialize Kaboom, you just call the Kaboom function and pass in an object which is gonna have a bunch of how do I say, options. So first let's specify a width. Let's start with 256 pixels and a height of 144. Later on, this is the resolution of the Game Boy, but wider, so it fits within a 16:9 ratio. We're gonna set the letterbox option to being true. That means that basically our canvas is gonna scale regardless of the screen size, basically, and while keeping the aspect ratio. And we're also going to set the global property to being false. The reason we want to set the global property to being false is that we want to only be able to use Kaboom related functions from this constant. That's why you need to set it to false. Now, in our constants.ts file here, we're going to create one constant. Really, it's the scale of the game because the current resolution is too small, and it's also going to act as a workaround because in Kaboom.js there is a bug, an issue, where pixels sometimes they don't get drawn right. So you will have, let's say we have a sprite, maybe to illustrate, I'm just going to pull this out. So here our Kirby-like character, for example, you will have it drawn where you will have the image, the sprite will draw, all right, but one pixel is wider or smaller than another pixel. And to fix this, the workaround I've found is to set a scale to a value and then go to the Kaboom context and then, first of all, add the scale property. And here, first, let's import the scale constant. And then by JavaScript, you know that you can, if you have a property that has the same name, you don't have to do scale like that. So you can just do it like this. It's a shorthand. So the scale is the constant set to 4. This is what looked good. But also you need to multiply by 4 here. This is a weird workaround that I've found, but it works. So yeah. And so I recommend just using it for now. If you found a way to get around this issue, then feel free to add a comment in the comment section and share it with us. Okay, so now we have our context. That's great. Now let's go back to main. And in main, we're going to have I'm going to import first our context, import K from the Kaboom context we just created. And then here we're going to have to load our sprites. Okay, so the way we're going to load our assets is going to be a bit different from other projects we've made on the channel. I'm going to create an async function. I'm going to call it game setup. Now for now, let me reduce this. Let me remove that. Okay, so we have the game setup, and in there we're going to call all of our logic, and afterwards we call game setup here. The reason we're going to do this is because we're going to want to load the assets once, and when the player dies, we don't need to refetch the map data. We don't need to refetch the assets or something like that. So to avoid, actually this is really to avoid having to refetch the map data coming from tiled, which is going to be the editor we're going to use to draw our maps, and it exports to a .json file, and we don't want to, every time the player dies, to redo the fetch logic to get the level layout and then redisplay it, etc. So by just having everything done within a async function, where we can use the await keyword to wait for the map layout to be extracted before moving on, this is going to be really helpful in not having to repeat this logic. So for importing the sprites, really I'm just going to copy and paste because this is logic that you just have to I'm going to explain it, of course, but it's a bit tedious and no new concepts or anything like that is really present. So I'm just going to explain what everything is first. So here, by using the K, which contains all Kaboom functions and methods we can use the load sprite method. This is how you load sprites in Kaboom. And by the way, because you're using a bundler like Vite or any other bundler, you're gonna have this some info on how to use the functions you're using and examples. So that's pretty handy. So the first key, the first param, is the name of the sprite, how you want it to be referenced in your project. The second one is, of course, the path to the project. And here the path is just ./Kirby-like PNG, even though we're putting our assets in the public folder. And the reason for this is simply because the Vite is going to make sure that if you put this, the path here is going to append or make sure that it references the public, what's outside as well. So this is something specific to Vite. I don't know if other bundlers do this, so you don't have to do ./public/Kirby-like PNG. And then we have a slice 9 and slice 10, and the way to explain this is how to slice your image, because our image, our sprite, has much more than a single sprite within it. So it's a tile set basically. And here you can see that we have one, every sprite is drawn as a 16 by 16, has a resolution of 16 by 16. That means that we have 1, 2, 3, 4, 5, 6, 7, 8, 9 different sprites on the x-axis, and that's why if I go to main.ts, slice x is going to be 9 because we have 9 sprites, 9, in the image. And then here for the vertical axis, we have 10. So you can just count them manually, but I think it's obvious. And now here is where we define the various animations. Basically, you're telling Kaboom which key corresponds to which thing you want to display in this image. So for example, for curb idle, so the main character is called Curb. So it's a Kirby-like. It's not that original of a name, but it's just for a tutorial in the end. So curb in the idle is a name I've decided to name this animation, which only contains one frame. And the first frame, remember that it starts from 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, etc. So at frame 0, you have this idle sprite. So this is the idle sprite we're going to use, and we're going to use this name to refer to it. For Kirby inhaling, so as you know, Kirby can inhale enemies. Well, it's the same thing. It's just a single sprite, and it's the sprite at index 1, 0, 1. And then curb full is when, so I guess you get the point. And then here, when you want to have an animation that has more than just a single frame, you use an object like this, where you specify a couple of keys. The first one is the from key, and you're basically telling Kaboom at which frame to start the animation. Here from frame 3, it's going to be this inhale effect. So this thing, and just to put it in action, just to show it to you. All right, so just to show you the curb inhale animation, it's this thing. When you're inhaling, you have a couple of pixels that just seems to give the effect that there is some inhaling going on. Here we go. So now if I go back to main.ts, so from frame 3 to 8, and then at a speed of 15 frames per second, this is what looked good, and I want this animation to loop. So you can decide if you want the animation to just play once or to loop forever, and we want it to loop until we just decide to stop it. So that's why I used the loop property as being true. Shooting star, it's the star here that the player shoots once they're full. And basically it's the same thing, the same logic for the various other entities. So copy the code if you haven't already, or you can pause here. So this software is called Tiled, and it's used to draw maps. And here is a map I've drawn for the first level. And I have another one for the second level. So the way I'm going to go about it is I'm going to teach you how to use Tiled for the first level. And then for the second level, we're just going to use what I've already had. And this time around, it's going to be different. We're going to export, the way we're going to use tile is going to be slightly different from the previous tutorials. So let's jump right into it. So first of all, install tiled if not already. A link should be in the description. Now, there's one thing you need to do, because if you're using a big monitor, then everything should probably look very small. So to fix this, you go to Edit, Preferences, and then do Themes, and then you check mark the Use Custom Interface Font, and then you can here select the font size you want. And this way it's going to make everything much more visible. Now, I'm going to keep this as a reference as I draw the level, because otherwise it's going to be complicated. So I'm going to create a new map by going to File, New Map, and then you decide how many tiles you want and the width and height of each tiles. So here let's start with I think 30 by 30. You know what? I'm just going to look at the current map and see how many tiles we have. It's a 27 by 20 tile. So let's keep this. So here, new map, 27 by 20, so we can have exactly the same layout. And of course, every tile is going to be a 16 by 16 pixels. And here, don't touch anything. It's not necessary. All right, we have our tiles here. Or actually, we have our map, not the tiles we need to draw in. So first of all, we need to import a new tile set. And the way we're going to do this is you specify the source. So basically, browse to where you put the Kirby-like PNG in the public folder. Okay, so I have done this, so this is the path for me. Yours should be the same starting from here. And now 16 by 16 pixels, everything is all right. And then click OK. Now, once you have this, you can use the control and mouse wheel to zoom in and zoom out. So the only thing left is to start creating our various layers and placing things. So let's, of course, save. So the way you save, you do save as. I named it level.json, and I saved it as a level.1.json in the public folder of our project. So I just go here and I click. So yeah, this was a mistake for me. I just put it twice, so I'm just gonna delete this. But you should have it here. So once you have it here, we're ready to start working. All right, so now it's time for drawing. So if I look at my reference, we have the background as the lowest layer. So background. And what this is going to contain, so just make things easy for me, I'm gonna make everything non-visible. And here you can see the layout. So basically 1, 2, and then, okay, so 3 by 2. Okay. So I go here. I'm gonna select this 3 by 2. So this should be here. Yep. And then 1, 2, 3. 1, 2, and 3. I'm just gonna zoom in with the control and the mouse wheel so you can see what I'm drawing. So basically, you select tiles like this, and if you do control and select, you can also click, you can select more than once, more than one tile. So you can have something like that. And then here for this, I'm just gonna copy, so 2 to the side. Here we go. And then just draw it till the end. Doesn't matter really all that much. By the way, always save while doing this. And then another hill. So I'm just gonna copy those two. By the way, you don't need to do control. You can just click and drag, and you can select more than one. And here you're gonna have a big map. So you know what? I'm not gonna worry about having it exactly anyway. So this is just to show you. Afterwards, I'm probably use the same map that you have here, but for the level 2, as I said, I'm just gonna use what I already had. So here, okay, so this looks like this. Doesn't have to be exactly the same. Otherwise, we're just wasting time. Then you have like that. Then maybe this like that. And a final one here. All right, so this is our background layer. We're also going to need to add to the background layer some tiles like this. You're gonna see what they serve, what's their purpose. But this is really something optional. So I'm just gonna create a new layer. So by the way, in tiled there are multiple types of layer. You have the image layer if you want to put an image as a full thing, but you have the tile layer for tiles. The object layers, object type layers are for boundaries and spawn points, so where to put your characters, a way for you to know this. And let's create another tile layer, and this second one is going to be the clouds. So clouds, here we go. And then once we have the clouds, I'm just going to select the full cloud sprites and just start putting them here. As you can see, they can overlay on top. So just put a random amount, it doesn't matter. Save, of course, as you do this. Now, the next layer is going to be the platforms. So it's a tile layer as well. Platforms. Or platform? Did I call it platforms? All right. So for the platforms, let's not stray a lot from the layout. So that's the level. Okay, so I'm gonna use these two. Oops, these two. Wait a minute. No, that doesn't work. So, oops. Where should I put this? Okay, here. And then I'm gonna expand this like that. I'm going to put this like that. Here we go. So really not much to explain here. Just draw whatever layout you want. Then we're gonna need certain structures though, just so we can have the same thing. But this is not something I plan. I draw it on paper, but I don't think it's worth, copying exactly what I'm doing. Just use the proper tiles, explore around, etc. And then here I'm just gonna have a platform. Here we go. And I'm gonna expand that further. And then like this. I think that's it. And we need another structure that is similar. So let's have this here. Expand it downward. And then a couple tiles here. How many tiles is there? 5 tiles. 1, 2, 3, 4, and then 5. And I think that's basically it. We're almost done. Oops. Doesn't matter because you can just draw over it and it will replace the tile. Okay, so we have this. Let's put a signpost here to signify the beginning of a level. Let's put the exit door. Whoops. Here. And I think a couple of grass. Here, we need to extend the background, so here in the background, I'm gonna need this. And this. Make sure to change the layer, of course. All right, so I think we have our level, and then of course, still in the background layer, we can add this down. For the rest of the color, the full background, I'm gonna add this using Kaboom instead. It's gonna be more performant. Actually, it doesn't really matter in the end, but I think it's better to do it this way. Because the way I'm gonna use tile today is going to be very different, and basically, you're just gonna take the image and just use the JSON to draw the boundaries on top. So instead of drawing each tiles in Kaboom, we're just gonna take a PNG. So here you can convert as a PNG, and it's gonna be very simple. Okay, so now we have this. It's time to place our various colliders. So I'm gonna create a new layer on top, an object layer this time around. I'm gonna call it colliders. And now here, The way you draw colliders by using this square, this rectangle on top here. And then here's an example. You drag, that's a mistake. You drag, come on. So basically just draw like that. So you drag and drop various squares, rectangles, sorry. And this is going to define what is collidable and what isn't. And then here we go. So once you have done this, we're done with the collider layer. And now it's time for the spawn points. So for these spawn points, it's also going to be an object layer, and I think I call it spawn points. Okay, so I'm just going to rename. By the way, you can rename by just double clicking on the layer name. So spawn points. And now what's going to happen here is I'm going to use a pin instead. So you see the pin icon, use that. And let's put our Kirby-like character here. So let's put it here where the signpost is. And here you select a name, and I'm going to call it player. This is how we're going to differentiate between all the different mobs, etc. So player spawns here. The flame type mob are going to spawn here. So flame, whoops, I created 2 pins. Be careful not to create pins by accident, because you can, so to select one, you use this button here, then you click, and then if you have the pin selected and then you try to select another one, it's just going to add another one. We don't want that. So a flame character is going to be here and here. Flame, here we go. And then I think that's it. And we have our birds. So let's put 2. I wonder, yeah, it doesn't matter the position, you know. So I'm gonna select here, called bird, and then bird, and I think we missed the guy enemy. So the guy enemy is this one. I'm gonna let's put him here. I'm gonna call it guy. All right, you have everything done. So save, and now we're ready. Oops, I created a unnecessary spawn point. So we have our spawn points, which terms where the player spawned, where the flame spawned, where the guy spawned, where the birds spawn. I think the birds are spawning a bit too far. So let's bring them down a bit so they can have a chance to hit the player at all. So here it is, maybe like that. All right. So we have everything ready. So for the exporting process, you can just use the JSON as is. But for the image, we need to hide the spawn points, hide the colliders, and then go to File, and then Export as Image. And then it's going to tell you the path and only include visible layers. And everything else should be unchecked. So now export. Now you could have decided on the background color and included it, but let's not worry about this. So export that. And then now if we go back to our editor, you should have the level displayed like this. So you can have the level as a single image. And this is more performant for Kaboom to only have a single image to display that is relatively small and then scaled up than having to draw each tiles using game objects. There are ways around it. So you could use a UV quad texture, but this is more advanced. So I recommend using this method. It seems very simple and can have much more bigger maps than you could previously with Kaboom.js. All right. Now that we have this, let's go back to main and import the sprites. So k.load sprite. We need the level. We're gonna call it level 1, and it's going to refer to the level 1.png sprite image that we had. Okay, let's create our scenes. We're gonna have the way you create scenes in Kaboom.js is by using the scene function. You decide on a name and you pass this as a first param, level 1. And you can have, here we're going to use an async function. I'm going to explain later on why. And then, actually, do we need an async function here? I don't think we need it. We actually don't. Let's just have a normal error function that is going to contain the logic that is going to be executed when we go to this scene. So by default, you have to specify a default scene, and you can do this by simply calling k.go and the name of the scene, level 1, to go to that scene. Okay, once we have done that, we can write our logic from within. So first of all, let's set the gravity to being of 2100. This is what looked good. It felt good to play. And then here we're going to create a background for a game. Now here I think we could just put that logic outside. Actually, we're going to have to repeat it because each time for each scene the background changes. Because there is actually a set background function in Kaboom.js to just set the background for everything. The issue with it is that instead of having white bars here, it's going to just use the same color of the background, and we don't want that. We really don't. So that's why, yeah. Otherwise, we will confuse the player on where is the actual limit of the level, for example. So here, let's create our first game object in this tutorial. So a game object in Kaboom.js is everything that can be a sprite, a player, etc. So in Kaboom.js, you create game objects that use certain components. Those components come from Kaboom.js. You can define your own components as well. And depending on which components you add into this array, your game object will have different properties and methods that are usable on it. So I think this design is really interesting, and I haven't seen it elsewhere. I think that's what is called an entity component system, but I haven't had experience with any other one. So if you know if this is actually the entity component system, and if other libraries in other languages use it, feel free to say it in the comments. I'm curious. I want to explore it more. So we're going to use the rect component. Allows us to draw a rectangle by passing the width and the height. We can get the width and the height by calling the width and the height method of the canvas. So that's it. We want the rectangle to actually fill the full canvas so that it acts basically as a background. Then for the color, we're going to use the color component, and in there we're going to call the color class, I guess, and use the from hex method. So it's probably an abstract class, and pass in the value for the background color. And here I just gone into a sprite where I've drawn the sprite and just took the color palette. So the color for the background is this. And wait a minute. I need to add another component. I'm gonna add the fixed component. This is useful later on. It's going to make sure that this game object is not affected by the camera, and we don't want it to be affected by the camera. Otherwise, if the camera moves, then the rectangle will no longer fill the whole screen because it's going to be positioned to the left as the player goes to the right, and the camera follows the player to the right. All right, we have everything we needed. So just to run the project, you do npm run dev, and then click on the link. And then you have just an empty background. All right, so now let's write the logic for making the maps. So for loading the maps and displaying them. So what I'm going to do is I'm going to write this code in the utils.js file, ts file, sorry. And let's go over it. So first of all, I'm going to need actually don't need the context here. What we're going to need is to import the scale constant. We're going to need to have this everywhere, basically. As I explained, is to prevent pixeling the pixels, to have two pixels that aren't drawn, that don't take the same space. It's very weird, a very weird effect. But it seems to be happening in Kaboom.js if you don't, for some reason, sometimes. So That's the only fix I found for it. So I'm gonna export a function, an async function. It's kind of required because we're gonna use fetch, and we're gonna call this make map. It's gonna take as the first param the Kaboom context. So the typing is provided by Kaboom. So all these things are gonna also come from Kaboom, and that's great. And the name of the map is going to be a string. It's also going to be the path. So it's going to be used to find the path of the level. So the first thing we need is to have a constant that will hold the, maybe I should increase the font size, by the way. Here we go. Okay, so we're gonna need the, to hold the map data within the map data constant here. And we're gonna use await, and then fetch, which is gonna fetch the JSON. So here we're gonna use a template string. So $name, which is the name of the map.json, and then at the outside.json to have it as a JSON. So you could have written this line in multiple lines. I assume that you know what fetch is and how to use it with async await, so I'm not gonna spend some time here. If you aren't familiar, look at my previous tutorials or just search online. I think it's gonna make a better explanation. So here we're gonna use the Kaboom function to make a game object. So in Kaboom.js, you can add a game object to the scene, which basically implies that you have to create it, or you can make it, and then you can pass what you have made into the add function later on, and this is going to add it to the scene and basically draw it. So here, because we're making this a utility function, we're going to first make the map. Once the map is made, we're going to pass it to the main, which is going to call the add function on it. So make really works the same way as add. It's just that it creates the game object but does not display it. So here we're going to use the sprite component, and this is where you can define what sprite you want. And here, because remember in main.ts we defined this sprite as being level-1, which is going to correspond to level.png. And here we have the JSON file for it, level-1.json, which we get from here. It's going to give us the map data. So if I look at the JSON export, you can see that you have layers, and each layer has a data property if it's a tile layer, or an objects property if it's a object layer, which gives us X and Y coordinates you can use. Alright, so here kmake, ksprite, etc. and kscale. It's the scale component where we're going to use the scale, so to scale the map, so the sprite accordingly. We're going to also use the positional component. So this is when you want to set the position of a character. You can use, or a game object, you use the position component. It takes in 2 values, but you can pass in only 1 if it's the same value for both X and Y. And here for now we just use the positional value and put it at 0, 0, so that the map is drawn from 0, 0. So the X coordinate 0, Y coordinate 0. Okay. And now we're going to have to get the spawn points. So here the spawn points are going to be X and Y coordinates that are going to define what we need, where to place the various enemies, players, and etc. And for now, it's going to be an empty object because we're going to get this data from the map data, but just get what we need and store it here. So the typing for this is going to be an object, of course, but first we need to define what the type of the key is going to be. So the key is going to be a string, and the value associated with it is going to be another object, which is of the type number, and Y also of the type number. This is going to make sense in a moment. All right. So now let's iterate through the map itself, the map data. So for that, I'm going to create a for loop const layer of map data dot layers. And if you've seen earlier on in the level 1 export, you can see that we have this layers property, that contains an array that contains all of our layers. Okay, now that we have this done, we're going to simply have an if statement that checks the name of the layer. So if the name of the layer is colliders, we're going to simply have another for loop, const collider of layer.objects. So here, basically, as I told you, if the type of the layer is a tile layer, it's going to have the data property, which is an array that tells us which tile to draw, etc. We don't need this for this project because we have already everything drawn as a single PNG. We just need to display that sprite. But for colliders, for object type, you have this objects property instead of the data property, which is an array containing the list of objects that is in this layer, which contains also the x and y coordinates for each of those objects. Okay. So now here for collider of, so by using layer.name, each layer has a name, and this is how we can differentiate them really easily. So for objects, which is going to be an array, so for each element of that array, so here I'm just going to call it collider, we're going to add to the map. So map was created as a game object by using the make. It isn't displayed yet, but one thing in Kaboom.js, you can have children game objects, and this is going to be handy here because we want to add to the map the various colliders. So the colliders are going to be game objects as well. Here you cannot use the make function. You cannot do, I don't think you can do this. So you need to use the add function to add it as a child to the map. And then once map is going to be called with the add function from Kaboom, then it's going to also draw the children of that game object. So to create a hitbox, we're going to use the area component, but defines a hitbox for you automatically, but you can specify a specific shape. So here the shape, I'm going to use new k-rect constructor, and it takes in as the first param the position relative to the game object. It's a vector too. And here, it's just going to be 0, 0. So a single value is enough. Now, then you need to specify the collider, the width and the height of that rectangle. And this is provided in the tiled export. If you look at the export here, you can see that for this object, we have the width and the height properties. That's very handy because we can now really know where to put those boundaries. Okay, so we also want to add another property inside of the area component. There's this thing called collision ignore, and we want basically you can pass in a tag, and is going to know if collision should be ignored with a specific type of game objects. So game objects can contain tags. We haven't covered this yet, but let's add them. Those are arbitrary names that I have defined, that there's this platform tag and the exit tag, which is for the exit door. It doesn't really, for now, it's not created anywhere, but it's going to allow us to differentiate our behavior. So just to explain, here, we're going to have a ternary statement, which is a basically condensed if statement. If the collider name is not the, actually I forgot to do this in tiled. So let's go back to tiled. So here in our collider, I forgot the collider for the exit. So here, I'm gonna draw, whoops, not here. So here, select the collider. You can make everything visible, it doesn't matter. And then draw this. Add its name, the exit, which is going to allow us to know that this boundary corresponds to the exit of the level. Save, and then if you go back to tiled, if the collider name, so now if I go here, I can see that there is one of them that is going to contain the exit name. So if the collider name is the exit, is not the exit, basically, is not the exit, we're going to add the component called body. And in Kaboom.js, this component allows us to have collisions affected by, collisions. And if you specify within it that it is a static body, is static, and you set it to true, then the current game object here, the child game object, is going to be remain static, and so that means that once the player collides with them, it's not going to move. So it's really useful for platforms. And then here I put it null. The reason I'm doing null here, it's a question mark. So the way it works is that if this condition is true, then you go here. If it's not true, it's null. So that means we add nothing, no components to our list. It's going to add null, basically, which does nothing. Here, regardless of the situation, we define the position, and it's just going to be collider X, collider Y. Nothing fancy. And that's basically it, right? And finally, a last thing. This is where we add the tags, actually. So if the collider name is not equal to exit, then this current game object that is being, this collider that is being added to the map is going to have the tag platform. So the way you create tags in Kaboom is just a string that you attach, that you add to your array of components. And the way it's useful is, it's useful because later on you can have event handlers, and you just listen on a tag to know if this game object has collided, or a class of a group of game objects have collided with another. Otherwise, so if the collider name is not equal to exit, and don't forget the comma here, we give the game object the platform property, not property, tag. So, okay, just to recap. If the collider name is not the exit, that means that we can give the tag, the platform tag, to the current game object, the current collider we created as a game object. Otherwise, we can give the exit tag. And this is going to be, later on, really handy. Okay, now that we have this, I think we have everything we need. And so we can continue here. So if after doing all of that, so it was the collider. Actually, continue can be outside of the for loop, otherwise it's useless. So here, continue. So if the for loop, okay, so if the first if statement is true, there's no point in going further. We just move to the next iteration, the next layer. And now here, if the layer.name is the spawn points, this is where we're gonna have a for loop const spawn point of layer.objects for that specific layer. And then we're simply going to have another if statement. If the spawn points object we created here has a spawn point dot name. Okay, so basically the way we're doing this is that if the property, the spawn point name, is already defined, so the spawn point name is going to be the name here. So player, we're going to have an object that is going to have all the keys. So this spawn points, you can use the key, for example, player, and it's going to give you the position of the player. Can you use the key guy? It's going to be the position of the guy mob. And we're making this. And here, this first if statement checks if it already exists. In case it already exists, we're going to simply add to the spawn points. So spawn points, so that assumes that there is an array. We're gonna write the condition below of if the spawn points for the specific key does it. So if the key doesn't exist in the specific in the spawn points object, then we're gonna just create an empty. We're gonna create an array, and then in that array we're gonna put the position, because we can have more than a single flame guy, a single guy mob, or a single bird. This allows us to be flexible. So if spawn point dot things going to make sense hopefully in a moment. We're gonna push to that array that we assume there is an array with x spawn point dot x, y is going to be spawn point dot y, and then we're gonna continue to the next iteration because there's no point in going further. Now if the key did not exist, that means it's the first time we're gonna have to create it. So we're gonna do this spawn point, sorry, and then spawn point dot name equal an array. X is going to be spawn point dot x, y is going to be spawn point dot y. And here it makes all the difference. It's because we created a what's the issue? We need to what did I miss? Did I miss something? Okay, so we have spawn point dot name, and then we push, and then push does not exist on the type. I messed up. I messed up in the typing here. It's an array. Okay, so it's an array of objects like this. You need to add this bracket. So now the typing should work. Okay, we have everything we need. So just to recap again, sorry if it's getting repetitive. If the key exists already in the spawn points object, then we just add to the currently existing array that we assume exists. If it wasn't the case, then we create that array and pass in the first member of that spawn point name. So yeah. Okay, we have everything we need, and then finally at the end, so right below here, we're gonna return two things. We're gonna return the map and the spawn points object. Those two things are very important. And that's it. So we can go back to main.ts. And right before we enter the scene, so after having loaded the sprite, we're gonna call we're gonna call map. So the map here is going to be called level layout, and the spawn points is going to be the level 1 spawn points, and it's going to be getting this from await. That's why async was needed, and then make map. It's going to import this automatically. We need to pass in the context and the name, which is level-1. Now, one thing I want to cover is this. You might not be familiar with this notation. What it does is it renames the map and spawn points properties to being level 1 layout and level 1 spawn points. This is going to be handy because when we're going to have two levels, we're going to have level 2 layout, level 2 spawn points. And because the make map function always returns a map and spawn point properties, if we were to keep the same names, it would make things difficult for us. So that's a JavaScript syntax. I don't think it's very common. I haven't seen this much beforehand, so in case you were like me and you didn't know what this meant, yeah, now you know. All right, so let's draw our map. So right below in the scene, you can do k.add and just pass in the level 1 layout, as I explained, and this should draw the map, the image. So let's look at the result. Voila, you can see it drawn, but you can't see it fully for now, but it works. All right, so before moving on, let's actually write everything we need for the player, the mobs, etc. And then we're going to come back here to main.ts and add them with the spawn points, etc. So to do something like that, go to entities.ts and let's write the logic. So let's first write a function that is going to be responsible for creating our game object for the player. to do something like that, same pattern. First we pass in the context. It's going to be a Kaboom context. So Kaboom context. So the typing comes from Kaboom as well. That's pretty handy. Then what we're going to need is to specify a position X, which is going to be a number, a position Y, which is also going to be a number. Once we have all of this, oh, well, my linter, yeah. So now we're gonna create a constant within, call it player, and call the kMake function that I explained earlier on. And here we're going to have a couple of components. Just to make things fast, I'm going to copy and paste it, copy and paste everything we need here, and then go over line by line. So of course we need the scale. So import this from this constants like that. Okay, so what do we have here? We have the sprite component that uses the asset sprites. If we go here, we named all of these assets, and then here optionally, the sprite component can take a second param, which is an object, and you can in that object specify the anim property and specify which animation you want to play by default. And we want to play the curb idle, which is, the name of the character, and it's frame 0. Then we create an area component. We use the area component to create a hitbox with the following shape. It's a rectangle with a width of 8 and a height of 10. And here it's going to be positioned at X value 4 and Y value 5.9 relative to the sprite. This is so the character doesn't look like it's sinking in the platform. You need to put the hitbox in such a way that it's going to make the character look alright, as if it's on the platform normally. This is a bit hard to explain without visuals. So let's first write this out, and then while you're going to open the debug mode, you're going to see everything. Everything is going to make sense. K.body here component, so that the player can be collide with other game objects and be affected by gravity. The position is going to be the position X passed in, but we need to multiply by the scale. And the position Y as well, we need to also multiply it by the scale so that it is placed at the right position. A scale component that calls the scale constant. This is to scale the sprite, and so scale the sprite so that the character takes the correct amount of space. The double jump component is something from Kaboom that you can specify a double jump and how much jumps you want to allow. So 10 jumps, so that it looks like the floating from Kirby, but it's not unlimited. And this is very easy. You just use that component. It's for free, so we don't have to write extra code to implement the feature of floating. So that's really great. The health component allows us to specify some health value, and then you can use the HP function method and the hurt function to know, and the heal function as well, to heal the life points, etc. So this is something that is handy in Kaboom.js. And the opacity is going to be set to 1. We use the opacity component. Setting it to 1 means that it's fully visible. This is going to be useful when the player is going to get hit. We're going to temporarily reduce the opacity to 0 so that it looks like it's flashing. And here, this is a new concept. Whoops. Is that in Kaboom.js you can pass objects as well as your components. So objects are going to contain properties that are going to be accessible immediately from within the game object. So if you do player dot, you can access the speed, direction, is inhaling, and is full. Those are arbitrary properties that I needed for the game. So the speed is to really control the speed, the direction for where the sprite is looking. It's going to be used for that. Is inhaling is going to be a boolean, and is full as well, that are going to be used to know when to allow for certain for the enemy to be swallowed or not, or inhaled, etc. And finally, the player tag is going to be useful. I think I'm using it later on to do the on collision logic, to know if it collides with an enemy, what to do. What we need to do though, right after, I'm going to use player.onCollide method. That is available if you use the body component in the, I think, the area component. And then as the first param, you specify the tag of the other game object you want to test collisions with or listen to collisions with, and it's going to be the enemy. We haven't created any enemies yet. That's normal. And when we're gonna do it, we're gonna add the enemy, basically, the enemy tag to those game objects. Now here, the async function, we're gonna need an async function for multiple reasons. Mainly, I think. Well, actually, do we actually need a sync function here? Yeah, we're gonna need it because we're gonna need to make the player flash and back and forth, and we're gonna use a tween for that. And it gives us much more cleaner code if we use the tween, the await syntax. And here, what's handy with the onCollide is that you can have the enemy game object passed in to your function here. So the second function is what runs when there is an actual collisions with the enemy. So if you have here async enemy, and then here we're gonna type it as a game object, and here you need to import a quick fix, import this type from Kaboom, and yep, so we are ready to write the content of it. So here again, I'm just gonna go faster. So here's the first if statement. If the player is inhaling and the enemy is inhalable, you're going to see this is going to be a property we're going to create later on when you're going to create the enemies. Then what we do is we set the inhaling to being false. We destroy the enemy. That means that the player inhaled the enemy so much that it collided with the player, and that means it's swallowed. So we can destroy the enemy by calling the destroy Kaboom function, where you pass in a game object to be destroyed. And then player is full is going to be true, and this is going to allow us to play another animation, and the one where the Kirby-like character is seen as full, and also is going to allow us to know if the player can now shoot a star. The second if statement we're going to need comes right after, and it's going to be this thing. Now here, global game state, we haven't created this for now, so let's replace this with level. Go to level 2 for now. Yeah, we haven't even created the level 2 as well. I'm gonna use the original, what I've already had in the original code base to go faster, because I think you get the point. So if the player HP, so HP is a method that is available since we have used the health component when creating the player object. And if it's 0, that means the player is dead. So in the case it was inhaling or the enemy was inhalable, we would return early here, so the enemy would be destroyed. But this is when the player hits the enemy by accident, or the enemy jumps on the player or something like that. Then if the HP is 0, then we destroy the player, and then we go back to, actually should go back to level 1 because we respawn. So we go back to the current level, and then we return early. And then regardless, so if this continues, that means that the player HP isn't equal to 0. That means we need to give damage to the player. So by using the hurt function, it's going to reduce 1 HP by default. And then you can specify a number if you want to reduce more or less. And then here is the logic that we're going to use for making the player flash blink. We're going to use a tween. So a tween allows you to change gradually a value from one value to another. And here we're going to use await because we want the tween to be completed before we move on to the next tween. So here, what this tween is going to do is it's going to take the opacity of the player, the initial opacity, and the target value is going to be 0. And the time we want to give to the tween to basically transition the player opacity from 1 to 0. So because currently it's 1, it's going to be done in 0.5 seconds. And this is the function that does the job basically of so every, I think, frame, it gives you a new value, and this value is set as the opacity. So for example, it's going to go from 1, 0.9, 0.7, 0.8, no, 0 0.7, 0 0.5, etc. until 0. And this is where you assign it, this value, to the new value of opacity. You can do this, dot opacity. And then finally, the last param is what is the rate of change. So it's going to follow a linear function. So it's going to be done linearly. And here, once this is done, because we have an await, because this is asynchronous by default, so if you were to not use the await, you could call this, and then the code is going to continue to execute while this is still running. So to avoid this, we first await that the tween is done. So we have our opacity that goes from 1 to 0. And then once this is done, we have our opacity going from 0 to 1. So this is going to give you the blinking effect. So that's basically it. Now we have finished the on-collide logic here for now. We're going to have to come back here later on to change here to not hard code this. But for now, it's fine. Now what comes next is another on-collide, but this time around with the exit. And this is the exit door we have created, the exit collider. And here it's going to, again, I'm going to replace this. It's going to go to the next scene. So on collide with the exit, we just use the go function from Kaboom to go to another scene, and by passing it the name. And then now it's time to do the whole inhaling mechanic. So to do this, what we need to do is create our inhaling effect. So this is the sprite animation that you saw earlier on that gives the impression that the Kirby character is swallowing something and inhaling something. And it's a game object that uses the asset sprite, but the specific curb inhale effect animation as default. It has a position, a scale, the same scale, and the opacity initially is 0, and we give it a tag. What we're going to do is that this animation is always playing, but we just tweak when it is visible or not, depending on the situation, depending on the player input. And then here, what comes after is the inhale zone. The inhale zone is a hitbox that is not visible. It just contains an area component with a given shape, which is going to be a rectangle. And what this inhale zone does, it will allow us to know when the player can actually swallow an enemy. And here again, we give it a tag. Those are going to come later on. We keep an empty position here because we're going to decide on the position depending on the direction of the player. This is what this next bit of logic does. So here we have an inhale zone on update function. So you can use the on update method on every game object, and it's even a function that is can be called independently. What it does, it registers an event that runs every frame as long as the game object exists in this particular form. And what it does is that if the player direction is to the left, we need to place the inhale zone to be -14 to 8. And because remember that the inhale zone and the the inhale zone is a child. So because the inhale zone is a child of the player, that means the position here that is specified here is relative to the player, to the parent. That's why it's going to be -14 plus the position of the player, which is the parent, but we don't need to worry about that. And here we can specify the position. We can replace the position by doing equal and then passing in a vector 2, which is just an x and y, a data structure for having x and y values and a signal structure. Yeah, this is offered by Kaboom, but it's pretty standard in game development. Here, the inhale effect position, we're also going to modify it, but because the reason here is that the inhale effect is not a child of the player, and the reason for this is simply because we need to be able to make it to hide it or not. And it seems that in Kaboom.js you cannot hide a child, so reduce the opacity of the child without reducing the opacity of the parent. So that's why I need to manually do a player position x minus a certain value and player position y plus a certain value to get the actual position I want the inhale effect to be in when the player is facing left and in inhale effect, we need to flip X. So the animation by default is drawn from the right side. So if you look at it here, from the actually it's from the left side, but we need to specify. Oh wait, so it's a bit hard to explain, but basically we need to flip the animation. So if it's on the left side, we need to flip it to being true, and on the other end, which is basically the logic that comes after here, we just do false. So that it goes to the other direction, or the default direction, which is the from the right. The swallowing is from the right or the left. I don't remember actually. And then finally, those are the last portion of code we need for the player. Here again, I'm gonna avoid this for now. Let's put level respawn at level 1. So here another update, but this time for the player specifically. If the player position.y is superior to 2000, that means in the canvas, the more you go down, the higher the value of y. So here, what it essentially is doing is that if the player falls and exceeds this value, then we respawn the player. So basically, it is considered dead. We respawn the player by just going back to the scene, which resets everything, the state of everything. So we don't have to worry about resetting value, health, etc. So it does this automatically. And then finally, we return the player in the function make player. So this is how we get a player. And I think we're ready to just test it out to see if what happens. So in the main, right below here, right below the add, let's create our curb character. Here's the code for it. So here we call this, I'm going to import, don't forget to import it. And then you pass in the K, and then level 1 spawn points, player, use the player key, and then there's only one player, so it's going to be at index 0, because if you remember, the spawn points are for each key, it's an array, even if there is only one, because there is the case where there is more than one. So instead of having to check when it's an array or not, we just assume that it's an array all the way. And if you know that there's only one player, you just do a 0. Past the index 0, and it's going to give you just the single player position X and Y. Now for the, actually we should have set the controls, but let's do that later. Now here, let's add the curb character to the scene, because remember in make player we just use the make Kaboom function, not the add. And let's write some logic for the camera. So the camera is really automatic in Kaboom.js. There's only a few things you can do. So you don't have to write a lot of logic in that sense. So here you can specify the scaling of the camera. So we want to have it at 0.7. This is what looks good for both X and Y coordinates. So here it's either you repeat, actually in the end, it's the same. So you could have decided to write 0.7 by 0.7, which is actually shorter to write. And then for the onUpdate function, this is an onUpdate that is general. So if you see here, register an event that runs every frame, not until the object is destroyed, because it's not attached to any object. And here we're just gonna make the camera follow the player in a certain way. So if the position of the curb character, the player, curb.pause.x, this is how you access the position, is inferior to the level 1 layout.pause.x, so the basically where the level starts, plus 432 pixels. This is what looked good. As long as it's inferior to that, we want the camera, so by using the campause method function, to be set at the camera, the curb pause.x plus 500, and then at the height of 800. So the y coordinate of 800. This is going to allow the camera to follow the player along a certain point and not exceed that point. Because if it exceeds that point, then you're gonna see the end of the level, or basically a way for you to avoid having to show more than what you want to show in the level. So if you're at the end of the level, you don't want the player to look very far to the right, for example. And here we add the position of the player plus 500, so that the camera is really, the player is going to find themselves to the left side of the screen, and there's going to be more space available on the right side so that the player can see farther along. This is something that It's really handy, especially if you're making a Sonic type game, because you want the player to be able to see as far as possible. For this type of platformer, it's not that necessary, but I thought it looked better. So now let's look at the result. I'm curious to see if there's anything, is anything going to change. All right, we can see our level, but now we don't have the movement controls, and this is what we're gonna deal with in an instant. Okay, so now that we have the camera working and the character being displayed, I think it's best to just start working on implementing the player controls so that we can truly see if the camera is actually working. So by player controls, I mean all the mechanics of the Kirby, so moving, swallowing, floating, etc. To do something like that, I'm going to go to the entities file, sorry, not folder, and in there, we're going to create a function right below. So this function is going to be called export function set controls, and it's going to take two things: the context, as always, but it will also take the player object. Now here I could have simply gone with the game object here as the typing, but we want it to be specifically for the player. So this is where we're going to create a new type. So the way you can go about creating types is either you create them all in a folder, in a specific file, and then you pull them out from there, or you create them where we need them. And really, here in this project, the current state of the project, I might expand the game later on, but on my own. But for the tutorial, really, we're not gonna export any typing really. There's only this type, and you could have decided not to use it, but I think it's best it's a best practice to create a specific type for the player, because there are some behaviors like you're expecting that the game object passed here in the set controls function is going to have some components, some necessary components. So the way you type a game object in Kaboom.js, you can take the default game object type and then add to it here the various components you need. So we want the following, so I'm just going to copy and paste it and then talk over the content. So this is going to go much faster. So here is the typing definition. Now all of these need to be imported from Kaboom. So update import from Kaboom. I should have just clicked here and I'll add all missing imports. All right, so to explain. So the player game object is a type that is a game object that has the sprite component, the area component, the body component, the positional component, the scale component, the double jump component, the health component, and the opacity component, and it has the following properties: the speed, the direction, is inhaling, and is full booleans. And this in make player, you can see that those were the properties here. So the goal of this is that if somehow you were to use this set controls on a mob, for example, which is just a regular game object, then you would have squiggly lines and TypeScript will tell you that, hey, you're not entering the correct type. So I'm just going to put player game object here. And now let's write the body of this set controls function. So let's do that. Give me a second. Okay. So first of all, what we need is actually, I need a reference to the inhale effect that we had. So I'm going to create a constant called inhale effect ref, which is this here in the original code base that we had. And this is a way to neatly get any game object you need, is you pass in the tag to the get function from Kaboom, here inhale effect, and it will return an array containing all the game objects that have this tag. So here we're expecting one, so I'm just gonna take the one at index 0. This is going to be useful because here in the controls, in the input, is where we're gonna decide whether or not to show the inhale effect of the Kirby-like character. So really, we need to start coding the player movement. The way you do this in Kaboom is by using the onKeyDown function. and it passes to you the key that is being pressed. So here I could just have a switch case statement. So switch key here. You could have left it as an if, but it's more concise to use a switch case statement. It's a matter of preference. So also sometimes it's clearer to just use if statements. So for the left case, we're gonna first set the direction of the player like this, since we previously decided that those are the properties we needed, and because we created them, we added them here, they are available to be modified in red here, in as long as you have access to the game object for the player. So here we're gonna change it to left, or set it to left, regardless of what the previous direction was. We're gonna flip the player horizontally by using the flip X property. This is offered by Kaboom if your game object has a sprite, uses the sprite component. So we're gonna have true, set it to true here regardless. And then finally, to move the player, it's in Kaboom.js, it's really simple. You call the move function and passes in a velocity, an X velocity or a Y velocity. Here we just pass in the player's speed, and Y velocity is 0. So the player is going to move here to the right, but you have to do minus to get to the left. This is very simple. And then of course, you have to break. Otherwise, the other cases are going to run. This is something like in JavaScript. I don't think in other programming language it's the case. Now we have the right case. And it's basically going to be the same thing. So I'm just going to copy and paste, but just different values here. And then after that, we have the Z case, the case Z. When the player presses the Z key, this is where we're going to basically make the character inhale. So simply within this, we're going to have an if statement. If the player is full, then we need to play the curb full animation. Curb full animation. Once this is played, or is playing, we can show the inhale effect. No, actually hide the inhale effect by setting the opacity of the inhale effect ref to 0 if it were visible. And then we break here. And then in here, and then right below, we are still in the Z case. If that was not true, so the player was not full, that means it's time to let the player inhale. So is inhaling is going to be set to true. And then we're gonna play by calling the play function the curb inhaling. That's the name of the animation. And we're gonna show the opacity. So we're gonna set the opacity to 1 so that we can show the inhale effect. So now that we have this, we can break for real as well here. And then we need to, when using a switch case statement, to have the default, which is gonna be empty in this case. So now we should be able to move left and right. Let's look at it. So if I maybe I should refresh the page. Oh, I haven't called it, so it's not gonna work. So if I go to main.ts and I go right before adding it to the scene, let's call the set controls function. It should be imported automatically and pass in the curb character. Of course, the context first as well. Now, if we look at the result, I should be able to move, and then when I press Z, I'm making the sound effect with it. But for now, you see that even if I left, I stopped pressing the key, Z key, the animation is still going on because we need to have a handler that checks when we release a key as well. And by the way, if you press F1, you can see the various collisions here. So yep, let's go back to the code base. Let's go back to the entities code. And here I'm just going to collapse the onKeyDown function. Now on key press this, let's implement the jumping first, I think. And then we'll go with the onKey release. So here, same logic. We pass in the key. Oops, not page transition. You know what? I'm just going to copy the code just to be fast and then talk over it. Maybe I should start just doing that for all tutorials. So key on key press, we have the key here. Here, this feels like unnecessary code. You could have just have a simple if statement. I'm gonna leave it though, in case you want to make allow multiple characters to be used for jumping. And here we can use the double jump method. And the reason we can use that is because we used, when defining the player game object, the double jump component. So this is what allows the Kirby-like character to float, to jump 10 times basically. Okay, now here it's time to do the onKey release. So onKey release. Here you go. And then again, here it's a switch statement. I don't remember if it's going to be that much useful. It's a single case. You know what? Just to make the code better, you know, if key equal x. Let's remove all this unnecessary stuff. Let's not over optimize, or yeah, and even this is not necessary. And then I of course need to remove that for the linting, the formatting, sorry, to work. So here, if the key you do this. Actually, yeah. Anyway, yeah. There could be say that the switch case statement syntax is not that concise. So yeah. Okay, so on the onKey release, we have the key, and then here I'm gonna use a if statement instead of a switch case again. And here, if the Z key is pressed, we're gonna do a bunch of stuff. So here, if the Z key is pressed, and we have another if statement. Usually I don't like that, having multiple ifs within. Let's keep it as is for now, and I'm gonna see if it makes the code any more difficult to understand, or if it can be improved later on. So if the player is full, we do something. So we need to play the curb inhaling. So the reason we're playing the curb inhaling animation when the Z key is released, if the player was full, that means they swallowed an enemy, is because the animation, so the image for both swallowing, inhaling, and shooting or spitting out the enemy, the star, is going to be the same. I thought it would work for both cases, so that's why it's playing this animation here. Okay, now let's do a const here and call it shooting star. And this is going to be a game object that basically the projectile, the star. We're going to create it. It's a disposable game object. We just create it here, and we write everything we need for it here. No need for modularizing. Though if you were to expand this game and maybe make, you know what a good exercise you could do with this is try to make implement the copy abilities of Kirby. So Kirby, except for the first game, not only can he inhale enemies and throw stars and stuff like that, but can inhale enemies and then use their powers, so become a fire Kirby, etc. Okay, so for shooting stars, yeah, we just going to need to use the sprite component. And here, the animation we're going to specify is shooting star. I think we already defined it earlier on. And we can also set the flip value, so the direction from which you want the animation to play within the second param. Because this is very disposable and we won't need to change the direction afterwards, because what happens is the projectile is shot and then it just goes to the, and as soon as it either hits an enemy or a wall, it will destroy itself. So here we can do a simple, depending on the player direction, if the player direction is equal to right, then this expression will evaluate to true. And if it evaluates to true, that means we need to flip X. So that means we're going to flip the star to be at the right direction, because by default it is to the left, like that. And that's basically it, I think. Yep. Now we can continue on. So k.area. Here, I'm going to have a shape. Now here, you can tweak these values. So I'm just going to copy over the code that we need. If it's at all possible. Let me just copy the whole thing. So I'm going to copy just the rest of the code for this game object. And I'm just going to go over it. So here we have a specific shape, which is a rectangle with this offset and then 6x6, etc. By the way, if we look at the output and I press the F1 key, you can see the box, the hitbox for the Kirby-like character. So here, and depending on how you position the sprite, I made sure to position the sprite a bit above. That's why the offset here was a certain value. I think it was, where it was, 4 by 5.9. Play with those values and you're going to see what happens. And get a better understanding than me trying to explain it to you with words. Okay, so we have the shape of the hitbox defined here. Then for the position, it depends. If the player direction is to the left, then the player position .x is going to be minus, we're going to take the player position to the, we're going to take the x position of the player and do minus 80. Otherwise, if it's to the right, plus 80. And this is so that when you shoot from the left and the right, it corresponds, you know, because the star is mirrored and it's going to go in a different direction. So play with those values, you're going to understand. Here for the Y, there isn't much difference between either right or left direction. So it basically, this what looked good, taking the player position, the Y position of the player, and then adding it 5 to it. You can play with those values if you'd like. And then, of course, we need the scale component as I started this game because, as I said, the pixels aren't going to be drawn properly where one pixel takes 1 pixel space, but a second pixel can take 1.5. And this distortion is a bug in Kaboom.js, and the way to fix it I found is this. It doesn't happen always, so I think it depends on your resolution. So if you were to make a game that is of a higher resolution, you wouldn't have this issue. I didn't have this issue very much before. So it really depends on the resolution you pick, it seems. And then here, depending on the direction, we can use the move component. The move component will just move the sprite, the game object, towards a direction. So that's the first param. If you hover over it, you can have a direction. It's either a number or a vector 2. And here I'm just using the constants provided by Kaboom, which is the left and right direction. So if the player direction is to the left, that means we need to make the shooting star, move to the left. Otherwise, we need to make the shooting star move to the right. And then we add the shooting star tag here so that we can later on have a, not later on, just right now, basically. I'm just going to copy and paste it as well. So right outside of this definition, I'm going to have this onCollide event listener. Actually, yeah, this tag is going to be useful, I think, later on for other things, other event listeners, because we don't need the tag because we already have a reference to the shooting star here. So if the shooting star onCollide with the platform tag, so with any game object that has the platform tag, then k.destroy is using the Kaboom function to destroy the shooting star. So that's basically it. And then here it's done. And then finally, what is needed is simply to put the player is full back to being false, since the Kirby-like character has just shooted the star, so that they should be able now to swallow someone else, another enemy. And then we're gonna use the wait function from Kaboom that is going to wait 1 second before making the player play the idle, the curb idle animation. Curb idle animation. Here we go. Here, in case you didn't see it, here it is. So this is a Kaboom JS function to do that. And then we return early. The reason we return early is that if we don't do this, we can just go here and just set the inhale effect the opacity to 0. The reason we're gonna set it to 0 is because now the Kirby-like character has done inhaling, so we don't want to show the inhale effect. And then we set player is inhaling to being false as well, because they're no longer inhaling anything. And then we put the player back to idle. That was the case if the player was not full initially. So can we make this better by removing this if statement? I think we could have this as a second condition, and then I think it's best to just keep it as is. By the way, the source code is available in the comment not in the description, so feel free to refer to that if you want. Okay, I think our code is done for this, so let's try it out. Let's try the output. So I can jump, I can inhale, and then when I stop pressing, it stops, and then you can see the inhale zone in the hitbox, so looks nice. And then if I just go here, there's no level 2 for now. Okay, our game is working, and one thing about the camera, I said that it follows you up until a certain point and then it stops here. Oops, okay. And then one thing I noticed is that we don't see the little thing here at the bottom. So if I go back to main.ts and maybe instead of this I put 900 here, you see this, I wanted to see that, so maybe 850 is going to be a good value. But then again, this is due to the specific map we drew together instead of the original map from the original source code I made. Okay, maybe a bit more. 70 should be fine. Does it work? Okay, it seems to look good. Okay, now it's time to work on making the enemies inhalable. But before doing any of that, we should probably write the code for the enemies. So I'm going to go back to entities. I'm going to collapse this as well. Let's write another function for making the flame enemies. And to go fast this time around, I'm going to just copy and talk over it. I think it's going to be better. So here it is. But it expects the... Anyway, yeah, let's forget this for now. Okay, so we have this function called make flame enemy, and it's going to be the flame NPC here, enemy. So to make this, we need the context, we need a position, X and Y position. Then we use the same thing, but this time around I used the add function. That might be because we just created immediately. I don't think it's that big of a deal. Anyway, doesn't matter. For this game, it doesn't matter if you use make or add. Just that if you use make, you have to use add later in main.ts. So here we have a flame character. basically we set the animation, we set the scale, we set the position, which needs to be according to the scale. So that's why we multiply by the scale. Then we have the area, which is the hitbox for it. And then the collision ignore, which is it needs to ignore collisions with other enemies. The reason for that is, and we use the enemy tag here. The reason for that is that, for example, the bird is flying on top and then the flame is going to jump, and we don't want both to collide. We want both to continue doing their thing without any collisions. So that's why we ignore the collision if it does occur. So it has no effect on the game. We use the body component and then the state. This is something new because we're going to define the AI for this little flame character. And the way you do that is using a state machine, and a state machine contains basically different states. And then for each state, you need to define the behavior and what happens, what makes it go to another state, and what happens when it enters the state, and what happens when it remains within the state. So here, the state component Kaboom.js takes a default state and the list of all possible states. Here, I've defined my state machine as being two states, idle and jump. And we start with the idle. And here, finally, we have just add the enemy tag, and this is going to be useful for both this, so that the enemy can ignore collisions with other enemies. So, for example, two flame characters, if they were to collide together, we don't want them to have any effect. So we don't want them to push each other. And it could be fun and weird to not have enemies being able to collide with each other, etc. But it creates too much unpredictability. All right. So how do we define the state? So here, once you have used the state component, you use the onStateUnter function to define for this state what happens, what is run when we enter the idle state. And here I just use the Kaboom wait function, but this time using the await keyword. This is just so we have it sequentially. So the wait is asynchronous by default. That means if you don't put the await keyword, it's going to run, and the rest of the JavaScript code is going to run after it as well. While by using the await keyword, what it means is that we wait 1 second before moving on here. So that's why I wanted this await here, so that I don't want to move on to another state before we have waited 1 second. So once we wait 1 second, we enter the jump state. Once we arrive in the jump state, we define here what we do in that case. So on state enter jump, we just make the flame jump. And we can use the jump function provided by Kaboom if your game object uses the body component. And here we specify a jump force. This is just so like the name, it's the force of the jump, and it can be tweaked. And I think 1000 was the value that looked best. And then finally, once this is done, there is another thing you can define for the same state. It's called onStateUpdate. And here, as it says, register an event that runs every frame when in a specific state. So while we are in the jump state, we want to run the following. So if the flame is grounded, this is a function method provided by Kaboom if you use the body component. So so it basically checks for you if the flame is on the ground, on a platform. And if it's the case, then we can just enter the state idle again. And basically this is a simple AI. So just to make things clear, what this AI does is just it waits 1 second, it jumps. Once it hits back the ground, it enters back into the idle state, waits 1 second, and then jump again, etc. So it's not something fancy, but yeah, it's an obstacle, I guess. And then we return, of course, the flame. And then we return, of course, the flame game object. Now let's make this make_inhalable function that is going to be applied to all enemies. So right below set controls, I'm going to, again, copy and paste the code for it and then go and explain it. I think it's going to make much better explanation, so I don't have to focus on typing while explaining. And I don't waste time typing while I could be explaining. Okay, so here, make_inhalable. This is the function, takes the Kaboom context and a enemy, which is just a game object. So here we specify a bunch of onCollide event listener. So when the enemy collides with the inhale zone by using its tag, we make the enemy is inhalable equal to true. Now here, didn't exist before, so not only you can create properties, so you can create properties on the fly for a game object, and maybe it would have been better if here in the game object you want to create, you create the property first instead of just relying on this. But for this tutorial, I think it's fine. So if the onCollide, so if the enemy collides with the inhale zone, then we set is inhalable true. So the inhale zone is this. In the game, when I press F1, it's this part. And by the way, the debug mode tells you the position of each game object and also the tag. For example, this is a platform, this is the exit, and I think that's it. And this is the inhale zone, this is the player, etc. Okay, now that we have something like that, we have the onCollide end, which also exists. So as soon as the collision is over, maybe because the enemy moved away or the player moved away, then we set the is inhalable to false, so that the player could not inhale someone not inside of the inhale zone. Finally, we have also the enemy onCollide with a shooting star. This is where the shooting star becomes useful, and we run the following function. What is really handy with onCollide is that it provides you the game object that is the tagged here. So it pulls it out for you, and you can have access to it. So here I can just do destroy the enemy and then destroy the shooting star. One thing I want to make sure though is in set controls, maybe I wrote destruction logic here. Where is it? Here. Okay, I wrote for the platform here. So if the platform collides with the shooting star, then the shooting star is destroyed. But this is a different case that we have here in make inhalable, is if the enemy collides with the shooting star, we need to destroy both the enemy and the shooting star. That is here, provided here. And then here I use the player ref to get the player. So the same way I did it earlier on with another game object, I don't remember. And then here on update register an event that runs every frame as long as the game object exists. If the player if the player is inhaling and the enemy is inhalable, that means we can actually do the inhaling. And then here, if the direction is to the right, that means we're going to make the enemy move towards minus 800, so to the left, with a velocity, x velocity of minus 800. And if it's not the case, then we assume that it is to the left side, and then we make the character, the enemy inhaled, move to actually it's the contrary. So if the direction of the player is to the right, we move to the left, the enemy move to the left. Otherwise, it's the reverse. And that's basically it. And then now here, when I commented out make inhalable, I can just comment this back in. And then, yep, that's it. Now let's write in main.ts the logic for that. So right below where we wrote the logic for the player, let's do it. Let's do the same for the flame enemy, and it's going to be very simple. We just need a for loop, and here I'm just gonna import here and save, of course. So now const flame of level 1 spawn points dot flame, and then it gives you all the flame characters, mobs, and then you can just display them like that, create them, and that's it. Okay. Now, if I look at the result, make flame enemy is not defined. Really? Maybe I did not make flame enemy is defined. Maybe the import wasn't right. What do you mean it's not defined? Did I use the proper tag? Let's look at here. We have flame. If I look at the level 1, we have flame, flame, flame. Flame. Everything seems to be correct. So why it's not working? Let's look at. Okay, it's working. It's just it didn't refresh soon enough. All right. So as you can see, I can swallow and then I can shoot. I can swallow. Oops, I took damage, and then I can shoot. And that's basically the game. Everything from this point now is just improvement and increasing the scope. So here in entities, let's write the code for the guy enemy. I'm just gonna copy and paste it. So yeah, so let me just there's still some explaining to do. It's not exactly the same thing, but it's going to be mostly similar. So here I paste it, and then let's go through it together. So we have the make guy enemy function, takes in the same params as make flame enemy, basically the same components, just the different animations. And for the state, it's okay. Here I used is inhalable. I added it to make flame enemy, to the guy, but not here. So what we could do is just let's add it, just to make things correct. So I'm gonna add is inhalable. Gonna set it to true, to false by default. And here we go. Okay, so the state machine here is going to contain more states. It's going to take, actually this jump, I did not implement it. I wanted the character to jump after moving left to right. You can do that on your own, but it has 3 states: idle, left and right, and it starts at idle. So at the idle state, same thing, we wait, and then we go to the left state, we flip X false, we set it to false in case it were flipped to the right, which does occur when the right here, using right, when going to the right. And then we wait 2 seconds before going to the opposite state. And while it's doing this, while we're currently in the left state, then we move to the left at a certain speed defined here. And this is the same logic, but duplicated and just tweaked so that it's the same for the right. Now we flip X to being true, because the sprite here, the guy, is facing left instead of right. And then here we move with a positive value instead of a negative value. Now if I go back to main.ts and I go back here, it's another for loop, same logic. Import this if not already, save, and that's it. Now the last enemy is going to be a bit different. The bird enemy, it's not going to have an AI really. It's just going to move into a direction and that's it. And it's going to spawn continuously. So I'm going to remove this. Not remove it, I mean collapse it. And let's write the last function for the enemies. And then we're basically done with this. So here, I forgot to have the closing function. The closing bracket of function, sorry. Okay, so we have make bird enemy. Takes this time around 4 params instead of 3. Only difference is the speed, because it's going to vary each time we create a bird. So here we have a bird enemy, basically the same thing. And then is static being true. Now this, it isn't necessary to have it to be static. So let's remove that. And it's going to move to the left by default at a certain speed that is defined by here. And then we have the off-screen component, and this is something very interesting if you're planning on making a more expanded game, is that you want things to not render when they're off screen at a certain point, of course. Here, if the distance from the viewport is higher than 400 or equal, then we destroy the bird, because we just want birds that comes from the right and goes to the left indefinitely. And for all those birds that were to the left, then at some point we want to destroy them to free space, I guess, so as to our game not to have a frame rate that collapse and overwhelm our 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 web browser, I guess. Okay, so we make it inhalable, the bird, of course, and then we return the bird. And now what changes is here, instead of having a simple for loop, we're gonna have a for loop as well. And then here, of course, import make bird enemy. And here we're gonna use the loop function. So here for bird in level 1 spawn birds, we have here a constant that defines the possible speeds we want to have, 100, 200, 300. And then we use the loop function from Kaboom to basically loop. Every 10 seconds, this will run. So it's a cleaner syntax for set interval, if you're familiar with the JavaScript function for that. Now, make bird enemy is going to take in a random element from here. So it's going to randomly pick either 100, 200, or 300 by using this logic. So this is a common piece of code you see online, where you do the math random times the length of the array, then you floor it, and this gives you an element within the array that is random. And that's it. I think we have finished. So if I go back to the browser, you can see the guy is walking. And if I were to just shoot, now you see that they didn't appear. Okay, now I understand why I had his body static, because it's affected by gravity. So if I come here, so if you're far enough away, you're gonna see the star. Otherwise, if you're too close to an enemy and you shoot the star, it's going to disappear. The star is both the star and the enemy is going to disappear too fast, I think. And if you want better feedback, a better feedback loop for the player, I think it's best to change this. So as you saw, the birds are just falling down, and that's because we removed the is static, and we don't want that after all. So it makes sense to have here is static, so that it's not affected by gravity, the birds. Now if I go and I look at the birds, you can see they're coming in, and I can shoot them, and here we go. Now here it is. And then of course there's no level 2 for now. And you know what? I think I'm not gonna implement the level 2. I think try it out on your own. Try to create a second layout. Use the thing I've explained here and do the transition between. Yeah, I think it's best. And of course, you can reference the original source code. I have the GitHub repo. Feel free to download it, look into it, etc. So yeah, I think I'm gonna end the tutorial here, just not to make it too long. And of course, the concepts, I don't want to rehash the same concepts all the time, but I hope this tutorial really was clear, that you understood how to make games using TypeScript and Kaboom.js. So yeah, thanks for watching, and subscribe for more content. So is it running at 60 FPS? It is. All right, thanks for watching. Bye. All right, so I forgot a very important part of the tutorial, which is how can you actually publish your game. So when you're using a tool like Vite, like we did in the Kirby tutorial, you need to use you need to create a vite.config.ts file, and then here you do import define config from Vite, and then export default this, and then here you need to specify those those two properties. So the base needs to be /, otherwise when you're gonna do npm run build, you're going to get something that won't work. So if you open this using, for example, live server, what's in the dist folder, then it's going to be how do I say it? You're going to get an error. Now you need also to disable the minification in Vite. This is an issue with Kaboom.js specifically. I don't know in the future if it's going to still be an issue. So try it without and with. So once you have done this configuration in vite.config.ts, which should be at the root level of your project, what you should do is just run npm run build. So npm run build. and then it's going to run your compiler TypeScript code, etc. So if you then you should see a dist folder appearing, and this is the folder you need to zip. You need to zip this, and then you can put it on itch.io, for example. So here, if I right click and open it with live server just to test out that things are working, you can see that the game is actually working. All right, that was a little bonus that I forgot to include. So hope you're still watching at this point. Thanks for watching. Bye.